What was Newton's second law again?
It's the law of motion.
Is that the one about an object staying still unless moved?
No, that's the first law, the law of inertia.
You really know this stuff. Are you planning to study science?
Not really, I just pay attention in class.
Ouch, that's strict. Do you remember the stages of the water cycle?
Sure, evaporation, condensation, and precipitation.
Right, and the water goes back to the ocean, right?
Exactly. It's like nature's recycling system.
That's a cool way to think about it.
Yeah, science is full of invisible cycles like that.
You make it sound poetic. If I drop two balls of different weights, which one hits the ground first?
Neither. They fall at the same rate in a vacuum.
Really? I thought the heavier one would fall faster.
That is a common mistake. Galileo proved otherwise.
Science keeps breaking our assumptions, doesn't it?
Exactly. That is what makes it exciting.
What exactly happens during photosynthesis?
Plants use sunlight to turn carbon dioxide and water into sugar.
So they basically make their own food?
Exactly. And oxygen is the bonus we get.
That is a win-win for everyone.
Nature is pretty generous, isn't it?
So matter can exist as solid, liquid, or gas, right?
Yes, and under certain conditions, plasma too.
Plasma. Like in the sun.
Exactly. It is superheated gas with charged particles.
That sounds intense.
It literally is, thousands of degrees.
Is it true that DNA decides everything about us?
Not everything, but it sets the foundation, like eye color or height.
Can lifestyle change any of it?
Some things, yes. Genes interact with the environment too.
So it is nature and nurture.
Exactly. Both work together.
Why does iron rust when it is left outside?
Because it reacts with oxygen and water, forming iron oxide.
So that is what rust really is.
Yes, a slow chemical reaction.
Chemistry is everywhere, isn't it?
Even in your bike's metal frame.
Do you know how fast light travels?
About 300,000 kilometers per second, right?
Yes, that is hard to even imagine.
It means light can go around the Earth 7 times in 1 second.
That is incredible. It makes sense why space distances are so huge.
Yes, but still, the universe is enormous.
So energy cannot be created or destroyed, right?
Yes, it just changes form, like potential to kinetic.
That is the law of conservation of energy, isn't it?
Exactly. It is one of the most fundamental laws in physics.
It makes sense why everything connects back to it.
Yes. Even everyday actions follow it.
Can you name all the planets in order?
Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune.
You memorized that perfectly.
I use a mnemonic. My very educated mother just served us noodles.
Clever. I used to say, 9 pizzas, before Pluto got removed.
Poor Pluto. It is still loved, though.
What happens if one species disappears from an ecosystem?
It affects everything. Food chains get disrupted.
So even small changes can cause big effects.
Exactly. It is called the ripple effect.
It makes sense. Nature is more connected than we think.
That is why protecting balance is so important.
Why does the brain use so much energy?
Because it is constantly active, even when we sleep.
Really? I thought it rested too.
No, it processes memories and repairs itself.
So that is why sleep is important.
Exactly. It is brain maintenance time.
How do animals adapt to extreme environments?
Through evolution, traits that help survival get passed down.
Like camels storing water or polar bears' thick fur.
Exactly. Nature experiments through generations.
That is amazing.
It is slow, but powerful.
Why are volcanoes and earthquakes often in the same areas?
Because they both occur along tectonic plate boundaries.
So Japan's location explains why we have so many.
Exactly. It is on the Pacific Ring of Fire.
It makes sense. It makes me respect the Earth's power.
Yes. Nature is both creative and destructive.
Do you think solar power could replace fossil fuels someday?
Possibly, but we need better storage technology first.
Like advanced batteries?
Exactly. Energy is useless if we cannot store it.
It makes sense. The future depends on innovation.
I could not agree more.
Every living thing is made of cells, right?
Yes, cells are the basic units of life.
Even something as big as a whale.
Of course. Just a lot more cells.
It makes sense. Life is built from tiny bricks.
Nicely said.
Do you think AI will replace scientists one day?
Maybe not replace, but definitely assist them.
Like helping with data analysis or simulations?
Exactly. AI speeds up discoveries humans could not do alone.
That is inspiring, and a bit scary.
True. The key is to stay curious and responsible.
Do you think room temperature superconductivity is possible?
Personally, I think it is difficult.
Why is that?
Because the average temperature of the Earth is simply too high.
You mean because of global warming or something?
Not really. I am talking from a chemical point of view, not a political one.
Do you think nuclear fusion power is possible?
Personally, I think it is difficult.
Why is that?
Because there is no container that can hold the fire.
Can't it be done like nuclear power?
The temperature is on a completely different level.
Do you think quantum computers will change the world?
Definitely, but not as quickly as people expect.
Why is that?
Because controlling quantum states is extremely difficult.
Isn't it just a faster version of normal computers?
Not really. It is a completely different way of thinking.
Do you think AI will ever understand emotions?
Emotions? That is not really what it is built for.
But if it can process infinite possibilities, couldn't it simulate feelings?
Maybe. But simulation is not the same as experience.
So even a perfect calculation cannot create a heart.
Exactly. That is what keeps humans interesting.
Do you think human cloning should be allowed?
Scientifically, it might be possible. Ethically, it is complicated.
But if a clone has all your memories, isn't it still you?
Maybe it would act like me, but it would not feel like me.
So memory does not make a person.
Right. There is something deeper we cannot copy.
Do you really understand quantum mechanics?
Honestly? Not completely, and that is what makes it fascinating.
But scientists built theories around something they cannot see.
Exactly. It is like describing shadows to understand light.
So reality depends on how we observe it.
Maybe. In the quantum world, the act of watching changes the scene itself.
I heard quantum computers are super powerful.
They are, but only if we can control the errors.
Errors? Computers usually just fix those, right?
Not in the quantum world. Even measuring a bit can break the calculation.
That sounds impossible to manage.
That is why error correction is the real challenge, not speed, but stability.
I read that trillions of neutrinos pass through us every second.
Yes, and we never feel a thing.
How can something exist and not interact?
That is what makes them mysterious. They almost ignore matter itself.
So they are like ghosts of the universe.
Exactly. Silent messengers from the beginning of time.
If nothing can escape a black hole, how do we even know it exists?
We see its shadow, the light it swallows leaves a trace.
So even darkness has a signature.
Exactly. Absence can reveal presence.
That is strangely poetic for physics.
The universe often is.
Do you think time flows, or do we just move through it?
Maybe both. We feel it passing, yet it might already exist all at once.
So the past and future could be side by side?
Possibly. Einstein once said time is an illusion, but a persistent one.
Then why does it only go forward for us?
Maybe that is the direction memory points to.
Where do you think consciousness comes from?
That is the biggest mystery, maybe from the brain, maybe beyond it.
But can science ever measure awareness itself?
Not yet. We can track signals, not the experience behind them.
So even in the age of AI, the mind stays hidden.
Yes. Perhaps that mystery is what keeps us human.
They say gravity is not a force but a curve in spacetime.
Right. Objects just follow the bend of the universe.
So when we fall, we are not being pulled down.
Exactly. We are moving straight through a curved world.
That changes how I see everything.
Me too. Even falling feels like part of the cosmic design.
Our DNA is constantly damaged, right?
Yes. Ultraviolet light, radiation, even normal cell division can cause breaks.
Then how do cells keep us alive?
They use special enzymes that find and repair the damaged parts.
So life survives by fixing its own code.
Exactly. Every second, billions of tiny repairs keep us from falling apart.
What do you think is the chemical invention that helped humanity the most?
I would say the Haber-Bosch process.
The one for ammonia.
Yes. It made it possible to produce fertilizer on a massive scale.
And that changed everything.
Absolutely. It turned air into food and saved billions from starvation.
Why is solar energy still less useful than fossil fuels?
It is mainly a matter of energy density.
What does that mean exactly?
Fossil fuels were once plants that stored sunlight for hundreds of years before turning into fuel.
So they are basically sunlight concentrated over centuries.
Exactly. One day of sunlight is like static electricity compared to that.
Before Volta, electricity was just static sparks, right?
Yes, something you could feel but never store.
So what did Volta actually achieve?
He found a way to hold the spark, to make electricity flow instead of vanish.
That sounds like catching lightning in your hand.
Exactly. For the first time, humans could save electricity.
Volta learned how to store electricity. What did Faraday add to that?
He made it move. He discovered that motion itself could create current.
Just by moving a magnet through a coil.
Exactly. That tiny movement lit up the idea of generators.
So energy could now flow endlessly.
Yes, and from that motion, the modern world began to spin.
After Faraday made electricity flow, what did Edison do with it?
He gave it purpose. He turned current into light, sound, and motion.
So he made electricity part of everyday life.
Exactly. He built systems, generators, bulbs, power lines.
That must have changed how people saw the night.
It did. For the first time, darkness was optional.
After Edison's inventions, what made electronics possible?
The vacuum tube, it let signals grow stronger.
So it could amplify sound and light.
Exactly. It was the voice box of early technology.
That must have changed communication.
It did. For the first time, electricity could speak.
Vacuum tubes worked, but they were big and fragile.
Right. Then came the transistor, small, fast, and solid.
It turned electricity into logic, didn't it?
Exactly. It could decide yes or no with every pulse.
That sounds almost like thought.
In a way, it was the first whisper of digital thinking.
Transistors made computers possible, but early ones were huge.
Right. Thousands of parts, all wired by hand.
So what changed everything?
The integrated circuit, many transistors joined together on a single chip.
So machines started to shrink and think faster.
Exactly. When circuits learned to cooperate, intelligence began to multiply.
Integrated circuits changed the world, but what came next?
The semiconductor age. We learned to shape electricity itself.
You mean, not just to use it, but to design it?
Exactly. We could guide electrons with microscopic precision.
Like sculpting thought from light.
Yes, and that's how intelligence became material.
Once semiconductors grew powerful, machines began to imitate us.
You mean AI?
Yes. Circuits that don't just calculate, but learn.
That's strange, we taught them to think, and now they teach us.
Do you think they'll ever surpass us?
Maybe. Or maybe they're just holding up a mirror.
So after AI, what comes next for intelligence?
The quantum turn, where computation dives into uncertainty.
You mean quantum computers, right?
Yes. They use particles that exist in many states at once.
That sounds unstable, almost chaotic.
True, but in chaos, there's the deepest kind of order.